Hello my dear students, welcome back to NEET World. So today we will be discussing surface chemistry. Yes, we can expect 4 marks question from this surface chemistry in your class 12th chemistry part. Okay, right. So this session is exclusively for IPE for both Telangana and AP students. Okay, yes. And see guys, this is our C60 material. Yes, you can access this material for free of cost from our NEET World app. Okay, so just go to Play Store and download NEET World app. Okay, so once after downloading it, you just log in using your mobile number, then you just mention your class in the chat box. Then our team will guide you how to access these materials like maths, physics, chemistry for MPC and biology along with physics, chemistry for BPC students from our app itself. Okay, right, you can use them and you can make your preparation more effectively. Okay, right. So in the last sessions I have covered complete LAQs. Okay, and SAQs from other chapters are also completed and very short answers are also completed, right. So let's discuss this 4 marks question from surface chemistry. Okay, so here in this surface chemistry, yeah, so what is the first question here? What is the different types of adsorption? Give any 4 differences between physical and chemical absorption. See, first of all, what do we mean by adsorption? First here they are saying what are the different types of adsorptions they are asking now. So first of all, tell me what do we mean by adsorption? Adsorption. Okay, what do we mean by this term adsorption? See, if you have a surface like this, consider this is the metal surface we have, okay, or the liquid surface we have. Now the accumulation of particles, accumulation of substances over the surface of this solid or a liquid substance is called adsorption. Okay, so now what I am saying, see, let us say there is some gas particles here. Okay, so these gas particles are accumulating on the surface of this substance. Now what I can say, this process is called adsorption. What is this process called? Adsorption. Okay, now the substance which is providing this surface is called adsorbate, and the substance which is accumulating on the surface is called adsorbent. Okay, so these are the 2 terms to be remembered when you are studying about adsorption. Okay, yes, this is 2 marks important question whatever I discussed till now. Now when it comes to classification, now this adsorption can be classified into 2 types. One is a physical adsorption, that is also called physisorption. What we can say? Physisorption. Okay, and one more thing is chemical adsorption or chemisorption. These are the 2 terms to be remembered here. Okay, right. Now let us look into the differences, like 4 differences they are asking. Let us see into those 4 differences for physical and chemical adsorption, or physisorption and chemisorption. Okay, we can call it as physisorption or physical adsorption. Similarly, chemisorption or chemical adsorption. Okay, right. Now what do we mean by physical adsorption? See, this physisorption is due to weak van der Waals forces between the substances which are accumulating here. See, I told you there is some gas particles here, they are just accumulating on the surface. Okay, so these interactions are just because of weak van der Waals forces. So physisorption is due to weak van der Waals forces, whereas chemisorption or chemical adsorption because of its strong chemical forces. It means between these particles and this surface area we are saying now. So between these 2, adsorbate and absorbent, there will be some chemical interactions. Chemical, like might be chemical bond formation is taking place, or some chemical forces are responsible, like chemical bond formation is taking place. So this chemisorption, it is due to strong chemical forces, whereas physisorption is weak van der Waals forces. Okay, remember this. Okay, the next, enthalpy of adsorption is very low. Okay, and you can remember physisorption can be a exothermic process also mostly. Okay, right. So here you just remember enthalpy of adsorption is very low. For physisorption, what we are saying, enthalpy of this physical absorption is very low. It is around 20 to 40 kilojoule per mole, whereas enthalpy of adsorption is high for chemisorption. Okay, so enthalpy of this chemisorption will be high. It is almost something like 80 to 240 kilojoule per mole. It's a high value enthalpy. Here it's a low. Okay, so here physical adsorption is there now, so it can be reversible and it can be fast, okay, it can be reversible and it can be fast, okay, and it occurs, this physisorption can occurs at a low temperature, okay. When it comes to chemisorption, it is irreversible and it's very slow, okay. Here it is, physisorption is a reversible and fast, but chemisorption is a irreversible and slow process, okay. And remember, chemisorption occurs at high temperature, okay. Physisorption occurs at low temperature, chemisorption occurs at high temperature, okay. Now see, since it is occurs at low temperature, the decrease in decreases, see what happens if, see, physisorption occurs at low temperature now, so if we increase the temperature, the physisorption nature decreases, so physical adsorption decreases with rise in temperature. It means physisorption will be very effective at lower temperature only. If you increase the temperature, physisorption process decreases. That is what the line says here, okay. And here, since chemisorption occurs at high temperature, so it increases, chemisorption, chemical adsorption increases with rise in temperature, okay. Remember this basic difference, okay, right. If the first question is clear, just hit a like button so that I can confirm you are following the session, okay, right. And note, the one note point here, physical adsorption, like physisorption can be a multi-layer process. It can accumulate on layer to layer, layer to layer also. So physisorption, here gas can form a multi-layers, okay, while in chemisorption only mono-layer. So only first layer will undergoes chemical reaction with the surface, okay. That's why it is considered to be, chemisorption is considered to be mono-layer forms, okay. Physisorption can be a multi-layer, chemisorption can be a mono-layer, okay. Remember this. Next one here is, what is catalysis? That is the second question here we have is catalysis. What is catalysis? What is catalysis here? See, what is catalysis? How is catalysis is classified? Give two examples for each type, okay. See, so catalysis is means the process of making a chemical reaction very faster or very slower, okay. Depending upon what type of catalyst we are using for a particular reaction, the reaction can be fastered or it can be slowered, okay. If we are using positive catalyst, what it will do? It will increases the rate of that reaction. It means a reaction is taking place in some 2 hours. Yes, we can speed up this reaction using a suitable catalyst. Now what this catalyst will do? Yes, this catalyst will speed up this reaction. Instead of taking 2 hours, it can happen in some 10 minutes also, even in 2-3 minutes also, depending upon the type of reaction and catalyst used there. See, here you just read, the phenomenon in which the rate of a chemical reaction is altered by a foreign substance, that is called catalyst, which remains, yeah, so the catalyst we are using in the reaction will remains unchanged. It means it will faster the rate of reaction, it will make the reaction to happen faster, okay, speed up the reaction, but there is no change in the catalyst composition. It will remain unchanged, it remains unchanged chemically, okay, and quantitatively, okay. This process is called catalysis. Once again read the definition, the phenomenon in which the rate of a chemical reaction is altered by a foreign substance which remains unchanged chemically and quantitatively is called catalysis, okay. Remember this. Now catalysis is of two types. One is homogeneous catalysis, other one is heterogeneous catalysis, okay. So homogeneous catalysis means here the catalyst and the reacting substances are in same phase, okay. Physical state will be same, okay. The catalyst and the reactants are in same phase. That can be a solid, liquid, gas, but all of them are in same phase. For example, you can see carbon monoxide plus oxygen gas are undergoing reaction. These are called reactants now, okay. Now the catalyst used here is NO, nitric oxide, okay. So that is also gaseous substance only now. Yes, the catalyst and the reactants, everything is having same physical state now. So you can say this process as homogeneous catalysis reaction, okay. In the same way, here you can see 2SO2 plus O2, these two are gases only, and our catalyst NO here also is gas only. So the product formed here is also gas. So it means whatever the transformation you are seeing, everything is included in gaseous phase now. Our catalyst is in gaseous phase as like our reactants. So you can consider this as a homogeneous catalysis. Okay, clear? Clear? I hope it is clear. The next one is heterogeneous catalysis. What do we mean by heterogeneous catalysis? Here you can see it's very same. It's very easy. Just see, catalyst and reacting species, that is what reactants are in different phases. For example, reacting species are gaseous, but catalyst is something like metallic substance, solid substance. Yes, they have different physical states now. Yes, consider it as a heterogeneous catalysis. Okay, if all the reacting species and catalysts are having same physical state, homogeneous. If they have different physical state, heterogeneous. See here, N2 plus H2, N2 plus 3H2, gaseous substance reacting in the presence of iron catalyst is a solid substance, right? So giving you ammonia. So here reactants and the catalyst are having different physical states now. So consider it as a heterogeneous catalysis. Okay. So now you can remember, like production of ammonia using Haber's process. What is the catalyst used? Iron catalyst. Okay. And this follows, it is an example of heterogeneous catalysis reaction. Okay. Similarly, contact process used for preparation of sulfuric acid. Okay. So here for production of SO3, sulfur trioxide, we will be taking sulfur dioxide plus oxygen in presence of platinum catalyst. Okay, solid substance platinum. Okay, metallic form now. So we are going to get SO3. Okay, so here our catalyst and the reacting species are in different physical states, right? So you can say it is also heterogeneous catalysis. Okay. Note, what is the note? Already we discussed. Catalyst changes the rate of a reaction but remains chemically unchanged at the end. So whatever the starting way you are taking, same will be observed at the end of that reaction for the catalyst. Okay, there is no change in the composition of the catalyst, it will remain same. The next here we have what are leophilic and leophobic colloids or sols, I can say. Okay, so leophilic and leophobic sols. Okay, compare the two terms, compare the two in terms of stability and reversibility. So we need to define what are leophilic and leophobic, and also the stability of these two terms we need to compare. Okay, it's very easy, just listen here. See, we have classified colloids as leophilic colloids, leophobic colloids. Okay, how can we classify these leophilic and leophobic colloids? Yes, just listen here. Based on the affinity between dispersed phase and dispersed medium. See, first of all, see, a colloid, it is a colloid. It's a heterogeneous mixture of like heterogeneous system, I can say. It contains two parts. Okay, so one is a dispersed phase and other one is a dispersed medium. Okay, what I am saying, there is one dispersed phase and dispersed medium. This together forms a colloid. So now what I am saying, this dispersed phase will be dispersed in this medium. Okay, so these substances will be dispersed in this medium. Okay, that is what dispersion medium we are seeing. Okay, and that results to form a colloid. Okay, right. Now look at this. Based on the affinity between this dispersed phase and dispersed medium, we have colloidal solutions as two types. Okay, one is leophilic and the other one is leophobic. Okay, so what do we mean by leophilic? Okay, so leophilic means phile means what? It's love. Okay, so solvent loving species here we can consider as leophilic colloids. Okay, and here leophobic, it's a phobic, hating. Okay, so solvent hating species here is considered to be leophobic colloids. Okay, leophilic, leophobic. Okay, so leophilic, in case of leophilic, there will be strong affinity, strong interactions between this leophilic and leophobic amine. There will be strong affinity between this solute and solvent particles. Okay, in which case leophilic case. See, there is a strong affinity between dispersed phase and dispersed medium in case of leophilic colloids. Okay, So this is easily prepared by direct mixing. Yes, we can mix both of them and we'll get the lyophilic colloids. Okay, and it is reversible in nature. Lyophilic colloids are reversible in nature, and these are stable due to solvation of particles. Now whatever the solute particles are, dispersed particles are there now, that will be get solvated by this dispersed medium. That is what solvent here. Okay, stable. So these lyophilic colloids are stable because due to solvation of particles. Okay, so particles get solvated, that's why it is stable. Okay, now what are the example? Starch, protein, gelatin, gum and polymer solutions are some examples of lyophilic colloids. Okay, the next we have lyophobic solutions. Okay, these are again called as water heating. So what exactly here? So there is a very little or no affinity between dispersed phase and dispersed medium. Okay, there is very little and there is no affinity between dispersed phase and dispersed medium. Okay, these are considered to be lyophobic salts. Okay, this cannot be prepared by direct mixing. We cannot prepare this lyophobic salts by direct mixing. Okay, so it is irreversible in nature. Okay, these are unstable. Okay, since they are hit each other, it is unstable, you can remember. Requires stabilizers or protective colloids. Okay, so we need to add some stabilizers to make this lyophobic colloids. Okay, these are unstable, okay, and irreversible in nature. Okay, so here we have some points here to be remembered for lyophilic and lyophobic as a remembrance. Okay, see what are the examples? Like metals like copper, metals like silver and Ag salts are considered to be lyophobic salts. Okay, now lyophilic and lyophobic, what is the small differences we have seen? Solvent loving here, solvent hating here. Lyophilic is stable and lyophobic is unstable. Lyophilic is reversible, lyophobic is irreversible. Lyophilic can be prepared just by mixing this dispersed phase and dispersed medium. Okay, when it comes to lyophobic, it cannot be made directly mixing. Okay, lyophilic solutions particles are solvated, these are getting solvated, but here it is not getting solvated. Okay, remember this. Okay, next one is emulsions. What do we mean by emulsions here? Yes, now you have seen colloids now. So colloids, I told you there is two things, one is dispersed phase and dispersed medium. Okay, so emulsions, an emulsion is a colloidal system in which both dispersed phase and dispersed medium are liquids. Okay, so we can prepare colloids by mixing different physical states. Dispersed medium can be liquid. Now dispersed phase can be gas, liquid, solid. Like that, we'll get different types of colloids now. But out of that, I can say emulsions are those colloids which are formed when both dispersed phase and dispersed medium are liquid states only. Okay, so emulsions is a colloidal system in which both dispersed phase and dispersed medium are liquid. Okay, both of them are what? Liquids only. So best example here is milk. Okay, so milk, what are the things we contain? It contains some oily substance, I mean fats, and water liquid, like water quantity, right? So that's it. Cold creams and vanishing creams are examples of emulsions. Okay, so what are the examples of emulsions we have? Cold cream, yeah, so cold cream, here cold cream and vanishing cream and milk are the examples of emulsions here. So now there are some classifications here, types of emulsions. First one is oil in water. Okay, oil in water. So oil is dispersed in water. Okay, oil is dispersed phase and medium, here it is water. Okay, examples like milk, vanishing cream are the examples of oil in water. Okay, then next one is water in oil. Water in oil. So water is dispersed in oil. Okay, here butter and cold cream are the examples of water in oil. Yes guys, these examples are very important for your EAP set exam. If you are preparing, since you are preparing for IPE, definitely you need to write MSET if you are interested to go for any engineering entrances right now. So these examples are important, ma'am. So what are the examples of oil in water from the following 4 options? Yes, we can expect like this because in EAP set we have surface chemistry. Okay, you should not ignore this chapter. There is we cannot see in the NEET because this part is not there in NEET, but in EAP set we have. Yes, you need to focus on this first. Okay, yeah. So butter and cold cream are examples of water in oil type, and milk is an example of oil in water type. Yeah. So these are some applications. So where do we use emulsions? Like applications, ore concentrations. Ores can be concentrated using oil and water emulsions. Okay, right. Next, cleaning action of soap. Soap emulsifies grease and dirt in the water. Okay, that's what we'll study here, micelles. Okay, now what happens when we add soaps? Now it will form some aggregates, like micelles are formed. Yes, we are going to study here about micelles. No worries. Next, digestion of fats. Bile salts like emulsify fats, aiding digestion. Okay. Next, absorption of drugs. Many drugs and lotions are emulsions that aid absorption. Okay. Note, emulsions can be separated by heating or adding electrolytes. So how can we separate emulsions? By heating or by adding some electrolytes we can separate them. Okay. Now explain the formations of micelles. Okay, yes, with a neat sketch. Just you need to show the diagram also. Okay, so micelles are aggregates. Okay, micelles are aggregates of soap or detergent molecules formed in the water at a particular concentration known as a critical micelle concentration or micelle concentration. So what they are saying? Micelles are aggregates of soap or detergent molecules formed in the water at a particular concentration. So at a particular concentration we are going to get this micelles formation. You can call them as that concentration as critical micelle concentration. Okay. Now how these micelles are formed? Yeah. So we can say soaps are fatty acids, like fatty acids of sodium or potassium salts of fatty acids. Right now, sodium potassium salts of fatty acids we know. So sodium potassium salts of higher fatty acids, like carboxylate group is there and sodium will be there. Sodium ion or potassium ion will be there in the soap formula if you observe. Okay, it means there is R group. R group is what? Alkyl group now, like big chain of alkyl carbons are there. So that can be considered as hydrophobic group. What is that? A hydrophobic group. Hydrophobic. Okay, when it comes to this carboxylate ion, see there is a charge now. So this is a hydrophilic. Okay, what is this? Hydrophilic. So we have two things. Like soap contains sodium stearate. Yes, you can take any of the soaps that we are using in our daily life. So at the back side of it, they will include this sodium stearate. Okay, yeah. So this sodium stearate dissociates into carboxylate forms and sodium ion forms, Na plus. Okay, so each carboxylate has a long hydrocarbon chain. This is hydrophobic chain, and polar head group. So this is our head, that is polar head group, which is hydrophilic site. Okay, so now COO minus part is water attracting. Now what it will do? We know hydrocarbons will not dissolve in water, like greasy substance will not dissolve in water. Okay, because it's a non-polar substance. Yes, so we have a non-polar substance in our soap formula, sodium stearate, and here we have a polar formula, like polar head here. So this will attract the water. Okay, look at here. See, carboxylate group part is water attracting, where R chain is water repelling. Yes, this is water repelling. Okay, so at low concentrations, ion flows with carboxylate ion in the water. R will be out of water. So now what it will do? So this will be heading towards the water side, and this will be away from the water. Okay, therefore we are going to get something like this. Okay, let me show you. At critical micelle concentration, several ions aggregate to form spherical micelles. Okay, so inside the micelle, a non-polar tail is trapped. Okay, inside the micelle. So this one, see if this is water quantity, like this, we are going to get like this. So at here, it means at here, At here inside the missile the non-polar tail is trapped, okay, oil, grease, okay, that whatever the oily dirty substance is there, that will be trapped inside, okay. Now outside we have polar heads, okay, so and polar heads remains in the water, so this forms the cleaning action. This forms a cleaning action. This is how missiles looks like, okay, right. Yeah, so you just search for any animation if you wanted to know exactly how it is happening. Yes, you will get this, okay, but whatever the required information to present in the exam, this is enough, okay. You just need to write this and sketch the diagrams, okay. And one last question here we have is explain absorption, adsorption, sorption, describe difference between different types of adsorption, okay. So now here we have explain absorption, okay. So what is absorption and adsorption and sorption, okay. First absorption, see, the penetration of molecules through the bulk of the solid is called absorption. For example, you just take one duster, like we know not duster, or you take piece of chalk. What happens when you place in the water? You take one duster, I mean sponge, you take one spongy substance, you place in the water. What happens? It will take the water inside of that bulk matter, right now. Inside of that sponge, water will be taken. So it means that is called absorption. What I am saying? Absorption, okay. And you can also see water present at the surface of that substance also, that sponge also, okay. If water, like the absorbing molecule, whatever the species accumulating here, will be present only on the surface of that substance, you can say adsorption. If it is entering inside that matter also, inside that bulk matter also, you can say it is absorption, okay. If both are taking place, you can say it is a sorption, okay. Read the definitions now. The penetration of molecules through the bulk of the solid or liquid is considered to be absorption. It means if this is a spongy material, now what happens, if I place it in the water, what happens? It will goes inside of it, right now, okay. So this is considered to be absorption, okay. Now the concentration, now what do we mean by adsorption? You see, concentration of molecules of a gas or liquid on the surface of solid or liquid. It means, for example, here I have a platinum surface. Now what happens if I send any gaseous substance, what happens? It will only present on the concentrated only on the surface of this platinum metal. It will not enters into this platinum inside of it, inside of this bulk matter, it won't comes. Inside of the platinum metal, it won't comes. Only present at the concentrated only at the top, at the surface of this platinum metal, right now. So this process is called adsorption, okay. If it is entering inside also, you should call it as absorption, okay. If it is going into the substance, into this matter, you can say absorption. If it is only present on the surface, should call it as adsorption, adsorption. If it is happening both on the surface, inside of the bulk matter, you should call it as a sorption, okay. Read the definition of sorption. Yes, here both adsorption and absorptions occurs simultaneously. Yes, you can call it as a sorption. Yes, three definitions are over. See, adsorption example, adsorption of H2 gas on the charcoal. If gas, H2 gas, hydrogen is accumulating on the surface of the charcoal. Now what happens? That process is called adsorption, okay. Penetration of molecules to the bulk of the solid or liquid can be considered as absorption. See, piece of chalk piece absorbing ink, so this is absorption, okay. Sponge absorbing water, this is also absorption. Sorption means what? Both process, above these two processes taking simultaneously considered as sorption. Now just now we discussed what are the different types. One is physical absorption, physisorption, chemical absorption, chemisorption, okay. So physical absorption is physical adsorption is due to weak van der Waals forces, whereas chemical adsorption is due to strong chemical interaction between the like dispersed phase and dispersed medium, those things, okay, right. Now whatever we discussed, this is very important in terms of your IPE exam point of view, Okay, I hope whatever we discussed everything is clear. Okay, so in the next session we will again meet with one more topic for upcoming IPE exams. Okay, and yes guys, if you are also preparing for NEET, JER, EAP set exams, yes, we are conducting free live sessions every day in our YouTube channel here itself. Yes, you can join them and you can make your preparation more effective and more productive using those sessions also. Okay, right, you can mention your feedback in the chat box, and if you are expecting any topic, yes, you can feel free to write in the chat box. We will definitely cover them in the upcoming session. Thank you for watching.